Problem 12. Determine the value of each term in the sequence for 7n plus 7, 7n plus 7, where n represents the position of a term in the sequence. Complete the table below for each value. This is another problem where we just need to plug in the n values into the rule and get our terms that way. So for n equals 1, 7n plus 7 would be 7 times 1, n is 1, plus 7. 7 times 1 is 7, and 7 plus 7 is 14. For n equals 2, 7n plus 7 would be 7 times 2 plus 7, or 14 plus 7, which equals 21. N equals 3, 7n plus 7 would be 7 times 3 plus 7. 7 times 3 is 21, plus 7 would be 28. N equals 4, 7n plus 7 would be 7 times 4 plus 7. 7 times 4 is 28, and 28 plus 7 is 35. You can see that it's increasing by 7 each time, plus 7, plus 7, plus 7, which we would expect with this term 7 times n. Number 13, which of the following coordinates lie outside the star graph below? Well, let's plot them all and see where they all land. 0, 4, remember, our first coordinate's x, our second coordinate's y, just like the alphabet, x, y, z. X comes before y in the alphabet, x comes before y in your ordered pair. So for 0, 4, start at the origin always. If our x coordinate is 0, we're not moving right or left at all, but our y coordinate is 4, so we move up 4, 2, 3, 4. We're on the y-axis, that is inside the star. We're looking for the point that's outside the star. B, negative 6, 4. Start at the origin. X coordinate is negative 6. The negative direction for x is to the left. 1, 2, 3, 4, 5, 6. And the y coordinate is positive 4, so again we're moving up 1, 2, 3, 4. That's also inside the star. Next point is at negative 3, positive 3. So negative 3, x would be 3 to the left. 1, 2, 3. Positive 3 would be up 3, 1, 2, 3. It's definitely inside the star. That's near the center of the star. Must be D, but let's make sure. 4, 0. So start at the origin. X coordinate is 4, so I'm going to move 4 to the right. 1, 2, 3, 4. And the y coordinate is 0, so I'm not moving up or down at all. That is on the x-axis. It is outside of the star. That's the answer. The next question asks, most of the star is located in which quadrant? Well, you can see that most of the star is in this quadrant. And then we make our C. C for Colby, number the quadrants. C starts in quadrant 1, passes through quadrant 2, then passes through quadrant 3, and finally ends in quadrant 4. And most of the star is in quadrant 2. Number 14. Model the next two figures in the pattern. This problem is a little tricky. You sort of need to see what's staying the same in each figure and what's changing. These three on the right are staying the same, and these are changing. We have 2 here, we have 4 here, 6, 8. So figure 5 would be, we said the part that's not changing is the 3 on the right. And then we would have 5 of those in figure 6. Again, 3 on the right not changing. If you count the number of dots in each figure, we can use those to fill in this table. There are 5 in the first figure. There are 7 in the next figure, figure 2. Figure 3 has 9. Figure 4 has 11. Figure 5 has 13. And figure 6 has 15. We can see that it's increasing by 2 each time. So we start our rule with 2n, and then we check the rule. For n equals 1, 2n would equal 2 times 1, or 2, but our first term is 5, so we must need to add 3 to that and add 3 to our rule. 2n plus 3. 2n plus 3. Then check it for n equals 2. 2n plus 3, 2 times 2 plus 3, 4 plus 3 equals 7, and it does. So the rule is good. Okay, we'll pick up the video with